These first four examples are examples of linear functions. So I would like you to go down below and write linear function. Also, please put a 5 off to the side. It's not just -2, it's -25. Now, what we're going to notice about these four tables is these are points that belong to linear function. This is a different linear function, a third linear function, a fourth unique linear function. We can tell by looking at data points whether something is a linear function if it passes two of these markers. And we'll talk about what are those markers in order to be a linear function. Here's the first one. Please go off to the side. Please go off to the side of the x's. And we're going to ask ourselves, how do I go from -3 to -2? I'm going to add 1. How do I go from -2 to -1? I'm going to add 1. -1 to 0, I add 1 again. It's imperative. That's your showing work. That's you showing work. Let's go over here to the next table. We'll come back to the output values or y values later. Over here, let's do the same thing. How do I go from 2 to 4? I add 2. Please do not just put the value. We need to see, are we going up by adding 2, down by subtracting 2, or eventually we'll even get to multiplying. From 6 to 8, we're adding 2 again. Over here, how am I getting from -4 up to -1? I would have to add 3. How do I get from -1 to 2? I have to add 3. And from 2 to 5, I add 3 again. The last example, I am adding 5, and adding 5. So this is showing your work. But the second thing you have to do today is you have to put it in words. And I recognize you're in a math classroom, and I recognize you may be like, I don't want to write a whole sentence. You do have to write a sentence about this. So please, at the very top where I put the very first dot, you are going to write this with me. You ready? Okay. Input values. Input values, I will zoom that in for anybody who cannot see well. Input values consistently have equal lengths from one value to the next. Input values consistently have equal lengths from one value to the next. Part of the standard is you have to be able to write that to describe what's happening. So here's my work showing. That's all I had to do for work showing. But this is what I also have to have. So I look over here, I'm adding 1, adding 1, adding 1. That means I'm consistently doing the same thing. I consistently would have a length of 1 between each value. In the second example, I would consistently have a length of 2 between each input value. Can you guys go outside and play cards, please? In the third table, I consistently have an equal length of 3 between values, input values. And the last one, I consistently have a length of 5 between input values. Okay, here we go. For the next one, we're going to do something different. We're going to look at the output values, which would be the y values. If you do not know that, please write output above y and write input above x if you did not know those terms. So input and x's are the same, output and y's are the same. So I'm going to use a different color so it stands out here, and I'm doing the same thing. I'm checking patterns. How do I go from 4 to 5? I add 1. How do I go from 5 to 6? I add 1. From 6 to 7, I add 1. All the same. Let's go to the next one. How do I go from 8, -8, down to -11? -3, yep. I'm going to subtract 3. Nice job. How do I go from -11 down to -14? Subtract 3. How do I go from -14 down to -17? Subtract 3. Please do the same right now for the third and fourth table. All right, let's look over here. So here I am going up 5. So I'm going to not write just 5. I need to say what's happening. I'm adding 5, and I'm adding 5. Lastly, I'm going down. I'm going to go down 2, and down 2. So how? This is the second criteria. In order to be a linear function, we have two things. One, the output values consistently have to have equal lengths from one value to the next. Now here's the second thing. You ready? I'm going to make a little room over here. This is much shorter. The output values consistently have an equivalent first difference. The output values consistently have an equivalent first difference. So consistently, it's happening every time. Equivalent means equal. So this would be the first difference. It's 1, 1, 1. The first difference is the same. It's consistently equal. This is the first difference from one value to the next. It's consistently, so it's constant, equal. Again, it's consistently equivalent. It's consistently equivalent. We are done with the first one. Okay, let's look at the x values. So I'm going to go with the x values for each of these. Okay, so if I go from -2 up to 0, I just added 2. If I go from 0 to 2, I added 2 once again, and 2 to 4, I added 2 once again. Okay? -3 to -2, well, I went up by 1, plus 1, not just a 1, a plus 1. From -2 to -1, I went up 1, and -1 to 0, I also went up 1. Let's go to the last one. 1 to 3, I'm adding 2. 3 to 5, I'm adding 2. 5 to 7, I'm adding 2. There's also two criterias here, two criterias to be a quadratic function by just looking at the table of values and then, again, identifying is it quadratic. Here's the first one. You're going to write down exactly what you put for linear for the first part. Output values consistently, you need to all be writing this, consistently have equal lengths from one value to the next value. Exactly what we had for linear. Make sure you all have this down. Input values consistently have equal lengths from one value to the next. Consistently, so we're doing the same thing over and over. Equal, 2, 2, 2. From the lengths, from one length to the next. It's not like 2, 4, 2. It's 2, 2, 2, 1, 1, 1, 2, 2, 2. Okay, now we're going to check the output value. So let's check this. You ready? You have to be very neat here because this is just a tiny bit more work. You always have a calculator if you need it. How do I go from 2 down to 0? I subtract 2. Make sure you put a negative sign. How do I go from 0 up to 2? I add 2. How do I go from 2 to 8? I add 6. This is referred to, I'm going to be lazy here, this is referred to as the first difference. And I can see the first difference is not the same. How do I know that? -2, 2, and 6 are not all the same number. So what I cannot say, I will not write the outputs consistently have equivalent first difference. So now we're going to try the second difference. Let me zoom in so that you guys can all see this. Okay, this is a tough one. You ready? Alexis, to go from -2 all the way up to +2, what is the difference? How do I go? Is it a plus or minus, and what's the value? +4. So please do the same. From 2 to 6 is a +4. We can see we have the exact same number. So please write second, and we're going to be lazy, second difference. Okay? You're welcome to use a calculator. I'll do one more with you. Here we go. You ready? So if I'm at -27 and I have to go up to -12, I need to add 15. If I go from -12 up to -3, I have to add 9. If I go from -3 up to 0, I have to add 3. This is the first difference. We're going to try the second difference. Here we go, second difference. How do I go from 15 to 9? Well, I have to go down. How much do I have to go down? I have to go down 6. How do I go from 9 to 3? I go down 6. This is the second difference. We can see the second difference is the same. Okay, right now I'm going to press pause. Please find the first difference, and if it's not equal, like these are not equal, then find the second difference. So I'm going to come off to the side here. I'm checking this out. Okay, you ready? 0 to 8, I just went up 8. 8 to 32, feel free to use a calculator when you need to. I went up 24. 32 to 72, I just went up 40. Feel free to use a calculator. This is the first difference, and I can see these are not the same values. So we don't have the same difference the same. It means it's not linear. Now I'm going to check on the second difference. To go from 8 to 24, I need to add. And specifically, I need to add 16. From 24 to 40, I need to add, specifically 16. The second difference. So what we're going to do is we're going to copy down exactly what we did for linear. The output consistently have an equivalent, but we're not going to put first difference. We're going to write second difference. Let's write that down here. Get started. So we are working with cubic functions now. Let's go through this really quickly. So the input values is what I'm going quickly through, but the output values I'm going to take my time. I feel like most people feel pretty comfortable here by looking from -2 to -1. I just had to go up a +1, -1 to 0, 0 to 1, and 1 to 2. In the second set, -2 to 0 is up 2, up 2, up 2, and up 2. The last set is up 1, 1, and 1. Okay, are you ready? Kevin, when you look up above at the first two types, linear function and quadratic function, and you see what you have down, what could we write in this position that describes the input values? You can read right off your paper. What do you see here, Kevin, about the input values? They're equal lengths, so we're going to write input values consistently have equal lengths from one value to the next value. So we put that exact same wording that describes input values for linear, quadratic, and cubic. Consistently, so it's always the same, equal, 1, 1, 1, positive 2, positive 1. Okay, now it's time to look at the differences. Here we go. You ready? From negative, so we're looking at the outputs, from -24 to -3, I just went up 21. From -3 to 0, I went up 3 again, and then up 21. This is the first difference. I can see that those numbers are not the same, which means this is not linear. What do I do next? I check second difference. So to go from 21 down to 3, I have to subtract 18. From 3 to 3, well, there's no difference, so it's 0. From 3 to 21, I'm adding 18. These are not all the same numbers, so the second difference is not the same. So now we're going to check the third difference. Here we go. So to go from -18 up to 0, I am adding 18. To go from 0 to 18, I'm adding 18. Here, the third difference is the same. So when we talk about the output values, you're going to write the exact same thing. The output consistently have equivalent, but you're not going to write first difference or second difference. You're going to write third difference. Go ahead. Okay, let's do these two together just so you can get the hang before we flip to the back side and learn about two of the newer type of functions. These are all functions you should have learned in Algebra 1, 2. Okay, to go from -4 up to 0, I have to add 4. From 0 to 4, I'm adding 4. From 4 to 32, I have to add 28. Oh my goodness. And what is 108 minus 32? Let's check. 108 minus 32 is 76. So first difference, not the same. First difference is not the same. How do I know? Those numbers are not all consistently the same. Now I'm going to do the second difference. To go from 4 to 4, there's no change. So it's a difference of 0. From 4 up to 28, I'm adding 24. And I'm going to grab my calculator. To go from 28 up to 76, I'm going to add 48. So what you see in pink, 0, 24, and 48, that's the second difference. How do I know the second difference is not the same? Those aren't the same numbers. Okay, last thing. How do I go from 0 to 24? I add 24. From 24 to 48, I add 24. The third difference is the same. Okay, at this time, you have 1 minute to show your work for the first difference, second difference, and third difference of this last set. I have to go down 1, down 1, down 7, oh my goodness, and down 19. So the first difference, not the same. I'm going to move this to the side. This looks complicated. Okay, second difference. Okay, there's no change. I went down 6. I went down 12. Second difference in pink, not the same. Now here, I went down 6, and I went down 6 again. The third difference is the same. Alex, I want you to look at the x values. And by the way, I'm not going to tell Alex if he's right or not. I'm going to call on somebody else next. Listen closely. Alex, you don't have to write these down even right now. Just look up there and look at the x values on all three columns. -1, 0, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. What can you tell me? Tell me one thing you can see about those x values. +1. This is +1, +1, +1, +1, +1, +1. Okay. Every flip to the back side. What can we say? Read off your paper. What can we say about the input values? Ready? Go ahead. What can we say about the input values? Casey, read it to me, please. What can we say about the input values? Okay, here we go. Ready? Write this down. We only have one more left after this one. So here we go. Stay with me. Input values consistently. Help me out with that exact wording. What was it? Input values consistently have equal lengths. Is that what we said? From one value to the next value. So every function that I've reviewed so far today, linear, quadratic, cubic, and now exponential, they all say the exact same thing for the input values, the x's. They all go up or down by the exact same difference off to the side. Okay, now, here's the next thing we would do. I'm not going to have you do it because we're going to save a little bit of time. But what you would do next is you check, please don't do it, you check the first difference. And you're like, first difference isn't the same. Then you check the second difference isn't the same. So it's not linear, it's not quadratic. Then you check the third difference, and the third difference is not the same. Please do me a favor, and I'd like you to write this at the very top. We're already going to write down what the output is. The output values, have a proportional relationship from one value to the next value. The output values have a proportional relationship from one value to the next. Now, this would be natural. You're like, what the heck does that mean? Please go above where it says proportional relationship and just say multiply by the same number. Go above where it says proportional relationship and write multiply by the same number. Okay, are you ready? So we can start anywhere along here if this is going to be true. Let's do this. How do I get from 2 to 6 by multiplying? By multiply by 3. So watch this. We're going to go here. We're going to go multiply by 3. How do I get from 3 to 18? Or sorry, from 6 to 18? Multiply by 3. Now we got to check this one, right? So come up here, and anytime we have a fraction, we're going to put it in parentheses. So I have 2/3 times 3. If I get 2, I'm feeling really good about this. So 2/3 times 3 is 2. So here's my work showing. That's it. The output values have a proportional relationship. That means they multiply by the same number from one value to the next. Okay, then this constitutes data points from an exponential function. Let's do the next one. How do I go from 6 to 12? Times 2. But if you didn't know that, bring your phone up here, Casey. Put your phone up here. If you didn't know that, you take the second value and divide it by the first. We're going to go times 2. How do I go from 12 to 24? Times 2. 24 to 48 times 2. Again, if you did not know that, because maybe your multiplication is a little bit lower, you take the second number and divide it by the first. 12 divided by 6. That's how you get it. Again, the output values have a proportional relationship from one value to the next. Here we go. How do I go from 2 to 8? I'm going to multiply by 4, multiply by 4, and multiply by 4. Exact same thing is true. Now you're learning about something that's brand new that you maybe have never heard of unless you took notes yesterday. Please come off the side, write logarithmic. This is a logarithmic function. Logarithmic. I'm going to press pause and give you a chance to write these down. If we look at these three and these three, do you see how all I did is I switched them? Do you guys see that? All I did is I switched it. So this negative 1, 0, 1, 2 went in from the inputs to the outputs, and the outputs became the inputs. Does everybody see how they just switched? Does everybody see that? So when we describe the logarithmic, we also have to switch these. So please write this down. It's going to start with, this is our last one today. It's going to start with the input values. Now remember, they switched. So the input values have a proportional relationship from one value to the next. Write that down. Input values have a proportional relationship. That means we're multiplying by the same number from one value to the next. And then you're going to write down the output values. See how we're consistently going up by 1, going up by 1, going up by 1. The output values consistently have the same lengths from one value to the next. The output values for here consistently have the same lengths from one value to the next. Mello, I'm going to call on you really quickly. Mello, can you tell me, looking at those input values, can you tell me what you recognize about the input values, the x's? That's awesome. He said it all with the wording. So he looked up here in his mind. He saw that we consistently added 2, so he said these words. He said the input values consistently have equal lengths from one value to the next. Awesome. If that's the case, it's either going to be linear, possibly, quadratic, possibly, cubic, possibly, or exponential, but it will not be logarithmic. Okay, here we go. Now we're going to check first difference, second difference. So here we go. So from 8 down to 0, I'm subtracting 8. From 0 to 8, I'm adding 8. Make sure you are putting this down since I'm helping you. From 8 up to 24, or sorry, 8 to 32, I'm adding 24. Are these numbers the same? No, the first difference is not the same. That means it's not linear. Let's do the second difference. From negative 8 to 0, oh my goodness, that's going 16. And from 8 to 24, I'm adding 16 again. This represents the second difference. This represents the second difference. Melanie, if we have the second difference the same, and that's for the output values, and our input values consistently have equal lengths from one value to the next, which function is it? Quadratic. Everybody put a Q here for quadratic. Okay, last one and then you're out. Here we go. Let's make it an easy one. I'm putting in a grade for you next for today, but you have to get this one done. Ariel, can you look at the x's and the y's and tell me which one has a consistent equal length from one value to the next? Orlando's going to help you for the purpose of time. Orlando already recognized it's the output. So plus 1, plus 1, plus 1. Okay. But now, there's only one of the 5 that has the outputs being saying that you have the consistent difference from one value to the next. I need to figure out how do I get from negative 1 to negative 2, and negative 2 to negative 4, and negative 4 to negative 8. What am I doing? Oh, you would think subtracting first, but then you're going to realize that it's not consistent. So we're going to multiply by 2. 2 times negative 1 is negative 2. Negative 2 times 2 is negative 4. Negative 4 times 2 is negative 2. We have right now we have this relationship. It's a proportional relationship that's consistent. What do we have if the input has a proportional relationship that's consistent, and if the output has consistent equal lengths from one value to the next? What would this be called? Logarithmic.